Good morning, madam. My name is Aravindan from DBT1A. Today I'm going to conduct a virtual lab which is test for ions. So firstly I'm going to test aqueous sodium hydroxide region. So which ions does aqueous sodium hydroxide test for? All cations and nitrate ion if aluminium was added and mixture is warmed. Okay, correct. How should you add aqueous sodium hydroxide? Add 2 or 3 drops of aqueous sodium hydroxide. Observe, then add the excess. Check. Correct. Portion of B, add aqueous sodium hydroxide until a change is seen. 2 drops of aqueous sodium hydroxide was added in solution P. State the observation by filling in the blank. Green precipitate was formed. Okay. Excess sodium hydroxide was added to solution P. State the observation by filling in the blanks. When the excess sodium hydroxide was added to solution P, the green precipitate was insoluble to the solution. So green precipitate form was insoluble in excess aqueous sodium hydroxide. Check. Correct. Given that the green precipitate insoluble in excess sodium hydroxide was formed, deduce the cation present in P. It was ion 2. Check. Correct. Finish. Now I'm going to test for aqueous silver nitrate region. After aqueous silver nitrate region was added, there was no observable change. Hence, deduce which ions could not be present in solution P. Calcium carbonate, iodide, and chloride. Check. Correct. Test for barium nitrate region. Why must the mixture be left standing for a few minutes? To allow the precipitate to settle at the bottom, hence relieving its color better against the colored solution. Check. Correct. Given that after adding aqueous barium nitrate and leaving the mixture to stand for 5 minutes, green precipitate was formed and sank to the bottom. Given that also there was no observable change when aqueous silver nitrate was added in task 2, deduce the anion present in solution P. An ion that present in solution B was sulfate anion. Sulfate. Check. Correct. Finish. All those tests were finished. Thank you, madam.
Good morning, madam. My name is Aravindan from DBT1A. Today I'm going to do an qualitative analysis test about how to detect an sulfate ion in unknown solution. So today, these are the materials that I'm using. Unknown solution, high purity water which contaminate with sulfate ion. So barium chloride solution, hydrochloric acid, dropper, and some wet floor. So this is the test tube that I'm going to use for. So these are the 2 ml of unknown solution, high purity water which contaminate with sulfate ion. So now I'm going to place hydrochloric acid with the dropper, which is 2 ml of 6 mole of hydrochloric acid. So I'm going to place 20 drops of hydrochloric acid. Now I'm going to stir the solution until it becomes acidified. so that I can continue with barium chloride solution. So now I'm going, now the solution is being acidified. So now I'm going to place a barium chloride solution, which is 10 drops of 1 milliliter of barium chloride solution in the unknown solution here. So which is 10 drops here. 4, 5, 6, 7, 8, 9, 10. So now I'm going to swirl gently to see the observation. So when I swirl gently, so we can see that a barium reacts with sulfate ion and form barium sulfate, which is a white precipitate and which is insoluble in water. We can see the white precipitate up here. Okay, madam, that's all. Thank you, madam.